Hi everyone, in this video we're going to be making this extendable ladder blueprint. Now what I mean by it being extendable is you can put the blueprint in sort of here where the top of the ladder needs to be. Let's just rotate that, move it back a bit, and then we can use this end of ladder variable to drag to add extra little extra rungs of ladder to get to be as long as we need to be. Once we've got it in place, it will work like any video game ladder. You walk into it, hold forwards to go up. When we're at the top, we automatically come off. We can walk back onto the ladder, hold S to go down. This is using standard WSAD controls anyway. It should work with an analog pad, I don't see why it wouldn't. Up and down the ladder and then detach automatically when we get to the ground. So that is what we're going to be doing. We're going to start here with a new first-person template project, and we need to first of all bring in the two meshes we're going to use, the one for the top of the ladder and the one for like the repeating bit with the rungs on. These are two FBX files here, which I've got links in the description. You can drag those into your content browser. When you import these, one thing, expand the mesh section and make sure that combine meshes is ticked. The reason is the top part would be two separate meshes otherwise, as you'll see in a second. Import all. The thing about smoothing groups doesn't matter for this, so you can just ignore that. Right, so let's have a little look at these meshes. The ladder top one is just this, the two little like hooks that go on top of whatever it is the ladder is against. Let's just give that whatever material, these are just the ones that are built in, let's say base material, and go collision, remove collision, because we're going to handle collisions with the ladder ourselves through a collision box, not through the mesh. The other mesh, ladder part, is there. And similar thing here, which we want to give it a base material. You can put whatever material you want on this, and then go collision, remove collision. And that's all the setup we need to do for the two meshes. You can see here, this is going to be the repeating bit that we copy over and over and over to make the ladder however big it needs to be. Before we make the ladder blueprint itself, there's a little bit of setup we want to do inside the player character blueprint. So I'm going to select the character in the world and just go edit first person character blueprint, or you can go through the content browser to the same blueprint. We need to add a variable for is the player on the ladder. So add variable, call it on ladder question mark. It should default to Boolean, but if it's not, just make it a Boolean variable so it can only hold a value of true or false. And now I want two functions. One that's going to run when we try and attach to the ladder, which we'll call climb ladder, and one that's going to run when we walk off the ladder, which we'll call leave ladder. So new function, call that one climb ladder. And this just needs to set up a few variables and change our movement mode to get ladder climbing to work. To start with, we'll say set on ladder, that variable we just created, to true. Then we'll drag in the character movement component because we need to change our movement mode via set movement mode. We will be in walking by default. We need to switch to flying. That will get us to be able to move freely up and down the ladder. Now another thing about character movement, if you look in the character movement component, go down to the flying section, there's a setting here, braking deceleration. Now really we want that on something really high like 2000, but if we permanently change it here, it will be set at 2000 for the whole game unless you say otherwise. We're going to make it so that we only set it to 2000 while we're on the ladder. So in the climb ladder function, next thing is going to be a set, movement braking, and you'll find one, there's quite a few called pretty much the same thing. We've got set braking deceleration flying. Set braking deceleration flying, and we're going to set that to something like 2000. That will stop us having this really kind of like floaty movement while we're on the ladder. And then the next function we're going to make, leave ladder, is going to be a copy of this function. So right click on the climb ladder function, press duplicate, and call that one leave ladder. And just basically change these three nodes. So instead of setting on ladder to true, we untick that to set it to false. Movement mode is going to go back to walking when we leave the ladder. And braking deceleration flying is going to go back to 0, which is what it was before we increased it. And that's all the setup we need to do inside the character blueprint for now, so we can move on to the ladder blueprint. The ladder blueprint is just going to be a new actor blueprint. We'll create a new blueprint class of type actor and call it BP_ladder. Inside here we need, the root component will make a static mesh component with those curved top of the ladder bits in. That's add component, search for static mesh, call that ladder top, and set that to use the ladder top mesh that we imported from the FBX file. And I want that to be the default scene root, so I'm just going to drag that static mesh component over the default scene root so it replaces it. So this is another fixed point that can't move around inside the blueprint. Everything else is attached to this, which is what we want. We also need a collision box. Search for that. Now, we're not going to set up the size and everything of the collision box here. We're going to do that through the construction script in a minute. And we also need a new variable, which I'm going to call end of ladder. This is going to be that variable that we can drag around in the world to say how big the ladder is. Make that variable of type vector. And then this is important, in the details panel, tick instance editable and also tick show 3D widget. If you compile, we'll go and have a look what that's done. If I drag a BP ladder up here and rotate it around, you can see that it's that end of ladder variable that shows up in the world, and you have to tick that show 3D widget, otherwise it won't. So this is what we're going to drag up and down, say how big the ladder is. Alright, now back in BP ladder, let's give that variable a default value of z minus 200. The reason is, if it defaults to 0, we won't be able to see any ladder pieces being added inside this viewport. So with it at minus 200, when we start adding ladder pieces, it will do 200's worth inside this viewport so we can check that it's working. Now, speaking of getting it to work, we're going to do all of our procedurally adding ladder bits via the construction script. This is a special script that only runs on the developer's PC, not the gamer's, so we can use it to set up various things in the world or do little procedural modeling tasks, things like that. So what do we want to do first of all then? Well, we need to add multiple ladder pieces, so we're going to use something called the for loop, F-O-R loop, if I spell loop correctly, there we go. What a for loop will do is repeat whatever we attach to loop body a certain number of times. Now what we're going to put on loop body is going to be an add static mesh component. So yeah, that's like going to the drop down, add component and choosing static mesh, but we're doing it procedurally through Blueprint instead of like via this interface. The next question is, how many times do we want it to do it? Well, that's what we're going to have to wire into last index. Now, basically, how many ladder pieces do we want to build? Well, to do that, we're going to get that end of ladder variable and then ask for what's called the vector length. What is vector length? That's basically just how far away have we dragged that from the 0, 0, 0 position within this blueprint. So because the 0, 0 position is right against the bottom of these curved bits, it essentially means how far down have I dragged that end of ladder in the world. That's its vector length. How far down have I dragged it from where it started? Okay, and then we're going to need another couple of variables here. We need a variable called piece size, like how big is each piece. Let's add that, piece size. That's just going to be a float. So a number that can hold a decimal value. Now with the mesh, that if you've imported the same mesh as me, you need to set that to 59. If you're using your own ladder rung pieces, you'll need to set them to whatever the Z height of your mesh is. And while we're at it with our variables, let's add another variable called offset. This is going to control how much the collision box extends past the top of the ladder, because I'll go back to the world and show you in a minute, but let's compile and set that offset variable to 200. Basically, when the ladders are placed into the world, the collision box is going to need to extend up here a bit past the top of the ladder so that when we want to walk back onto the ladder to go down, we are actually colliding with that box. It just makes it, you can see the effect. If you don't have that offset on, it doesn't work as well. Alright, so how many ladder pieces do we need? Well, it's going to be the vector length divided by, and if you, for this division, if you search for the node called division brackets whole and remainder, and we're going to divide that vector length by the size of each piece. And if you think about it, the math checks out. We need to cover this distance with rung pieces. That's how big each piece is, so dividing one by the other tells us how many we need, so we can plug that return value into last index on the loop, and it will now create the right number of pieces. The next question is, where is it going to put each piece? Okay, so if we right-click on the relative transform input for add static mesh component and split it via split struct pin into location, rotation, and scale, then right-click on the relative transform location and split that again into XYZ. We can now just wire something into Z. So all we want to do is move these new pieces downwards. They're going to be moved down by, each one is going to be however big each piece is, multiplied by the loop index, so whichever piece we're on, but then we want to go downwards in distance, so we're going to multiply by -1. Might sound a bit complicated, but all it is this. How big is each piece? Then multiply the loop index. I'll explain what that is in a second. So it's int multiplied by float to do that. The loop index is just a running count of how many ladder pieces have been created. It starts on 0, as it says there. So the first piece is going to get moved down by 0 times piece size. So it'll be right at the top of the ladder. Next piece index will be 1, so it will be moved down by 1 times the piece size. So it'll be below the one we just made. Then the next one will be 2 times piece size down. That's all that is. Now, because we want to move negatively downwards in Z, we need to multiply the result of that multiplication by -1 to sort of negate it, and then just plug that into the Z. If you hit compile now, oh, we haven't set the mesh, right? If you go back to the construction script, on the add static mesh component node, in the details panel, set the static mesh to be ladder part. Okay, now let's see what that's done. See, so now that's started to add these pieces. And we could go into the world here and just start dragging around that through this. Now, I haven't made it so that you can only drag this up and down. That's how it's intended to be used. But of course, if you start dragging it sideways, it will still work. It's just a bit awkward. So I recommend only dragging that vertically like that. Right, perfect. Now the collision box, it's just sort of sitting there at the top, and that's not what we want. We want it to, the collision box to start from wherever the end of ladder variable is, go shooting up to offset amount past the top of the ladder. And that's just going to be a little bit of math here, back in the ladder blueprint, back in the construction script. When we've finished adding all of our static mesh ladder pieces, as in when this loop is completed, we're going to take our collision box, and first of all we're going to do a set box extent. Basically, how big do we want the box to be? And then after we've done that, we want to drag off the box again and do a set relative location. Relative location is whereabouts in the blueprint is this box located. I can show you that on the viewport. So set relative location is basically this, moving the box around within the blueprint. And set box extent is this, where you're saying what is the extent of the box. Except, again, instead of doing it through the interface, we'll be doing it through, through this details panel interface. We'll do it through the construction script. Now, the way the math checks out, if we just plug completed into there, we want to right-click on inbox extent and go split struct pin into XYZ, because we're not going to make a vector here, we're just going to do it as floats. Same thing for relative location, right-click, split struct pin. Now, the extents of the box, some values that seem to work for these meshes is if we hard-code the extent x to 32, the extent y to 60, so that's always going to be the same no matter how big the ladder is. It's the z that's going to change. The z is going to be the vector length again, so end of ladder get vector length. If I spell that right. Right, let me just search for vector length. There we are. It's not get vector length, it's just vector length. Perfect. Then we're going to add on that offset. So drag offset in, do a float plus float. There we go. And we just need to divide that by 2. The reason is when you're setting the extents of a box, you're saying how far does it extend in all directions from the middle. So if you're talking about if you've calculated the overall length in one direction like we have, you need to divide it by 2. Otherwise your box will be twice as big as it needs to be. Okay, there we go. And then for the box location, the way this checks out is if we just take the result of this division, multiply it by -1 to sort of invert it, and then add the offset on again, that will be perfect for our location Z. The location X stays on 0, location Y we want to be 40, so that moves the box to be just in front of the ladder, rather than sort of halfway embedded in it. And then, like I said, for location Z, we take the result of that division, multiply by -1, and then add on another copy of our offset, and you'll see the results of this in a sec. Plug that into Z, and then that's the construction script done. What we should have now, unless I've messed something up, is there you go. So wherever we put that end of ladder variable, that's where the collision box is starting, and it's extending upwards past the ladder by whatever that offset amount was, in our case 200, which seems to work well for the default character. Now we need to get this ladder to actually work. Now this is going to be back in the BP ladder blueprint to begin with. We're going to go to the event graph this time, delete the stuff that's there by default because we don't need it, and then for our collision box I want to add 2 events. The on-component begin overlap, which will run whenever anything overlaps that collision box, and the on-component end overlap, which will run whenever anything stops overlapping it, so when, say, the player walks out of the collision box. Now, we want our ladders to only work with the player, so we're going to check, was the other actor, the thing that overlapped the collision box, actually a first-person character, which we can do by going cast to first-person character. Of course, if you're using a different character class in your game, you'll have to put that in here, but on the default first-person template, it's cast to first-person character. Right, if it was a first-person character that touched the collision box, we want to run that climb ladder function that we set up earlier inside the player. And then similar thing down here, if other actor, cast to first person character, leaves the collision box, we want to run that leave ladder. If it wasn't a first person character that touched or left the collision box, it will run whatever we put on the cast failed, and we're just going to leave those blank. And that's all we need to do in the ladder blueprint. Everything else is now going to be in the character blueprint. Going back into the first-person character blueprint, go to the event graph, and we just need to modify some of the existing stuff that was set up already to take into account whether we're on a ladder or not. Specifically, this section here where we've got movement input and the move input axis move forward event and the move right event. Now I'm going to drag the comment box for those to be bigger because we need a bit more space. I'm going to move the move right stuff down out of the way a bit. And let's just look at the move forward. Let's talk about what this is actually doing. If you might not know, when you press on a keyboard W or S to move forwards or backwards using the default controls, axis value will either be 1 or -1 depending on which key you press. So if I press W to move forwards, axis value is 1. If I press S to move backwards, it's -1. Then all we're doing is taking our forward, we're moving forwards, but multiplying our forwards vector by either 1 or -1. So if I press S to move backwards, we're basically moving forwards by a negative amount, which is what moving backwards is in this. If you're using analog controls, pushing the movement stick all the way forwards will give you an axis value of 1, all the way back will give you an axis value of -1, and then as you move the stick in between, it will gradually rise up and down from -1 to +1. So analog stick, it doesn't necessarily have to be halfway forward, but let's say analog stick halfway forwards would give you a value of 0.5, halfway backwards -0.5. Right, just so you know what the axis value is. And all it does is move us. Now, what we want to do, before we do a move, we just put a branch in by holding B for branch and clicking, or right click and search for branch if you want to, and have a branch for our onLadder variable. Okay, if onLadder is false, just tell Unreal to do what it was doing before. So, whatever you were doing with all this, carry on doing that, that's fine. If we are on a ladder, we can also we're going to have this, the same add movement input. It's just we want a little bit more control over how we move. Now, what we're going to need to do first of all, if I just click and drag, put an extra point on that line and double. I mean, you can just drag that wire right from here, but I prefer to put these little reroute nodes in to keep things nice and tidy. You add those just by double clicking any wire in Blueprint. I want to check first of all, is that movement axis value greater than 0, yes or no, true or false? If it is greater than 0 and we're on a ladder, we're trying to move up the ladder. If it's less than 0 and we're on a ladder, we're trying to move down the ladder. If it is 0 exactly, nothing will happen, don't worry. We're going to use that true or false value in what's called a select vector. Plug that into the world direction. The world direction is what direction do you want to move, basically. And the Boolean goes in there. So now, if that's true, if movement axis, axis value is greater than 0, vector A is how we will move. If that's false, then vector B is how we will move. So remember I said it will be A if we are trying to move up the ladder and B if we're trying to move down. Now moving down is a simple case. Let's just right click and do a get actor up vector and just plug that straight into B. So if we're trying to move down the ladder, we'll end up moving up by a negative amount, and that's all that it needs to be. If we're trying to move up the ladder, we also want our forward vector. So get actor forward vector. Well, why do we want that? Why, if we're going up a ladder, do we want to move up but also try to push forwards? It's so that when we get to the top of the ladder, we'll automatically come off the ladder and start walking on the, whatever platform is at the top. So we take our forward vector, add that with vector plus vector to our up vector and plug that into A. So if we're going up the ladder, we'll go up but also forwards. If we're going down the ladder, we'll end up going up by a negative amount and we'll move down. And that's all we need to do for this. We could test this out, but in fact, we will test it out. There's one other thing we need to do to make it work properly, but let's just see how far we've got so far. I hit play, walk over to this ladder, see, touch it, we can go up. When we get to the top, we carry on moving. If I walk onto the ladder, I can hold S to go down. But then when we get to the ground, we don't automatically detach. So I'm holding S, but I'm still trying to move down sort of into the ground. Of course, if you turn around, you can hold W to walk away. But let's make that a little better, shall we? We want to automatically call the leave ladder function when we touch the ground. Now to do this, I'm going to add a new what's called object channel so that we can tag the ground as being ground. That's in Edit, Project Settings. Then you want to go into the collision settings under Engine and see here you've got object channels. Go New Object Channel and name that one Ground and leave default response on block. Press Accept. What that now means is if you go back to the level, you can select the ground, this big squarish ground mesh. Scroll down in its details panel to collision. Under collision presets, change that to custom. And then under object type, change that to ground. Right, so now the ground is effectively tagged as being an object of type ground. And you do this for whatever mesh is underneath your ladder. Back in the first person character blueprint, we'll find an empty bit of space down the bottom. We want to know when the capsule component, which is the character's collision component, we want to know when that touches something tagged as ground if we're on a ladder. So select the capsule component, scroll down to its events and choose on component hit. And then what do we want to know? Well, we want to drag away from other component here, not other actor this time. It's other component. And we want to do a get collision object type. Okay, so let's say, what type is this? What type of collision object? We want to drag off of that and do an equals brackets enum, equal brackets enum. And see, this is where you can say what object type was it that we hit, and we can find our new ground channel at the bottom there. Our new ground object channel, and then we can just check that true or false with a branch. I'll tell you what we'll also do, before we wire that in, we'll drag in the on ladder blueprint, drag from the enum comparison and just search for and, A-N-D, and wire those in, and then wire that into the branch. So now this branch will pass, will be true, if our collision capsule has just hit a ground object and we were on a ladder. And all we do is drag and drop in our leave ladder function and call that there like that. And we pretty much are done here now, guys. So we can just play. I go to a ladder, start going up. If I go down the ladder now, as soon as we hit the ground, we detach and can carry on moving backwards. So it works like a ladder does in most games. There, see? I mean, of course, if you're at the top and you run backwards at full speed, you won't go down the ladder, you'll just come flying off the platform like that, but you expect that. Now, just to test this works, let's do something similar to what I had in the intro video, where we will Alt-drag a copy of that block up there, go to the scale tool and just shrink that a bit, and then see whether we can get a new ladder in. Well, that's just going to be drag in BP ladder, go to rotate, and then move just to get that in the right place. Get the end of ladder, drag that so it's touching the floor like that, because it will automatically add as many pieces as it needs. Then let's go play and see if that works. Yep, seems to be fine. We can go up, we can walk onto the ladder and go down. Oh, fell off the ladder that time. We can go up, walk onto the ladder. There we go, start moving down the ladder again, and when we hit the ground, we automatically detach and are back to walking. So I hope you guys found that useful. That's how you make simple extendable ladders. See you next time.